In the 12th video in my series on how to make a 3D space shooter game in Unity, I show you how to make target boxes and display them on the enemy ships. I also show you how to display an indicator when we've locked on to an enemy ship, and we draw arrows around the edges of the screen to point the way to ships that are out of view. So grab your favorite beverage, pull up a chair, and follow along as I teach you how to write a 3D space shooter game in Unity. Okay, so I think one of the next things I want to work on is the ability to take advantage of these big launchers that we have on the ship to launch some seeking weapons. But in order to have seeking weapons, we need to have something to seek. So I think the next thing we need to do is implement targeting. So we've already got our reticle here, and we've implemented our health bar on the enemy ships. We've got the reticle so we can aim our blasters, but we need to have something more for targeting for seeking weapons. So we have these wonderful sprites that I've got that targeting reticle from. If I open this up here, you can see there's a lot of possible things that we could use. I was thinking something like one of these, like this box here, would be a good general target box to put around any target that's not currently locked on. I was thinking of maybe something like this for when you lock on to the target. And then this arrow here I think would be good for when the target is off the screen. It's within radar range, but it's not in front of us. This would give us an indication of where we need to go to get them on target. So I want to create a prefab. I'm going to actually create a sprite image here. And I don't want this to be part of the ship. It put it there because there's already a canvas, I guess, there for our health bar, but we don't want that there. So now we've moved him outside of the ship, and we are going to call this target box. And for our sprite, this guy here, and we want to make him red. And for our material, we'll just use the sprite's default material. And we'll go ahead and reset his position here. I think that is everything we need to do for that. Okay. And I'm going to create a child sprite. We don't want that canvas. So for our image here, we're going to call this one lock on indicator. So if we're locked on, we'll display this sprite. And I think I wanted one from the second sprite sheet. Let's see. That one looks good. And again, we'll make that red. And I think I'm going to want to scale that down a little bit. Okay. Again, I think that's all fine. Oh, material, we want to use our sprite's default. Okay, and then we can duplicate this. And I'm going to call this off-screen indicator. And we'll make that even smaller. And that one was down toward the bottom here. That was nice. I think I want the one that's facing up. Okay. All right, so I think that's good in terms of the image. For the location for this prefab, I want to create a new folder here and call it UI, because it really is a UI element. And I will drag that into there. And we're going to want a new script. And again, I'll create a new folder here. And I'll call this UI. And create a C# script. Target indicator. All right. Let's go ahead and get rid of all this boilerplate. And we're going to want some serialized fields. We're going to want a few images. We're going to want our target box image. We're going to want a lock-on image. And we're going to want the off-screen image. And we'll go ahead and import. I think we want Unity UI image. And we're going to want a floating point value. We want to have a little bit of a margin. Because when he's off the edge of the screen, we're going to display the arrow, and we want the arrow to be a little bit off the edge. So I want to have a margin there, and I may adjust that. We're going to need some private variables. We need to know what target we're tracking. We're going to need access to the canvas that this is being drawn on. And we're going to need access to the camera. And a couple of rect transforms. We're going to want our rect transform. And we're going to want to have the canvas's rect transform. And let's see. We're going to want to calculate the center of the screen, because we're going to need that to determine where we're going to put these indicators. And I'm just going to initialize that to vector 3.0 because we're going to overwrite that. And I'm going to add a property here called screen center. And in the getter, we're going to get our canvas rect. I'm doing this because we're going to reference this more than once in this calculation, and I don't want to have to unbox it more than once. So our rectangle will be our canvas rectangle's rectangle. So we'll calculate screen center.x to be rectangle.width times 0.5. And the screen center.y will be our rectangle's height times 0.5. And we'll just set the screen center.z to be 0. And we will return screen center, and we'll adjust it by the scale of our canvas rectangle on the x-axis. That will give us the center of our screen. Okay, now this guy is going to be part of a collection of targets that we're going to display. We're going to add a new UI manager, and the UI manager is going to maintain a collection of targets, and we're going to need some kind of an identifier to map the target transforms to their target indicators. So what we're going to do is we're going to add a property, and we're going to call it key, and it's going to be an integer. It will have a public getter and a private setter. And this is basically going to be the instance ID of the transform that this indicator is for. And we're going to want a Boolean value called locked on, so we know which indicator to show, whether we're showing the target box or the locked on image. And in our awake method, we need to get our rect transform. And we're actually going to display these things in the late update method. So the first thing we want to do is get the normalized position of our target. So vector 3, and this would be a viewport position. And we're going to use our main camera. We're going to call world to viewport point. And we're going to take the target's position. So this will take the target's position and convert it from world coordinates to viewport coordinates. And this is a normalized position from 0, 0 to 1, 1. And it will actually be negative if it's outside, or beyond 1 if it's outside the bounds of our screen. This will let us know if it's visible or not. So display target reticle on target. It tells me this is not spelled correctly, so I'm not sure how that's supposed to be spelled, but I'm just going to leave it. If target is visible, we're going to add a new method here, and we're going to pass in that target viewport position. Then we want to display an on-screen reticle. And again, we'll pass in that target viewport position. And we'll just return. We fall through if that's not the case, and we will display an off-screen reticle. Okay, so we're going to want a initialization method as well. Go ahead and stub these out. All right, let's go ahead and create an initialization method. This will be a public void method. I'll call it init, and it will take our target transform that we're going to be chasing and a reference to the main canvas. Which doesn't exist yet. Okay, so in here we're going to cache that target. We're going to set our key to be that target's instance ID. We are going to cache that main canvas. We're going to get the canvas rectangle from that main canvas. And we're going to cache the main camera. All right. So first, let's do target is visible. We're basically going to take that position that was passed in, and I'm just going to rename this position just so I have a shorter thing to work with. We're basically saying if position.x is greater than or equal to 0 and less than or equal to 1. And I don't need to wrap this in parens here. Position.y is greater than or equal to 0 and less than or equal to 1, and position.z is greater than or equal to 0. So we're in front of the camera and we're within the visible bounds of the camera. All right, that will tell us if it is visible or not. And I'm going to move this whole block of code up here. Now, display, we'll do the on-screen reticle first. So let's convert this screen viewport position to a screen point. So we're going to take our main camera and we're going to use the viewport to screen point and take that viewport position. All right. And we're going to set the Z position to be 0. And then we're going to save off our rect transforms position to be that. Oops. Okay. And we want to enable the target box based on whether or not we're locked on. And we're going to enable the locked on image based on whether or not we're locked on. And we're going to disable the off-screen image. And that should be everything we need to do to display the on-screen reticle. And for now, we're not going to do anything here with the off-screen. I want to get the on-screen working first. The off-screen is going to be a little bit more complicated. We're going to have to calculate angles from the target to the from the ship to the target. We're going to have to determine where on the X and where on the Y to draw the arrows. It's a little bit more math, and we'll cover that after. Okay. Now let's go start work on our UIManager. So under managers, we've currently got a game manager and a camera manager. So I'm going to create a new empty game object here, and I'm going to call this UIManager. And we're going to give him a canvas. This is going to be our main canvas. Now we do want screen space overlay, but for the canvas scaler, we want, instead of constant pixel size, we want to scale with screen size, and we're going to set it to match our default game display, which is 1920 by 1080. Okay. That all looks good. All right, we want to create a script for this manager. So we'll create a new C# script. Call that UIManager. And we'll open that up in the editor. Get rid of all this boilerplate. And we'll add some serialized fields. We need a target indicator, prefab. We need the canvas. So we want this to implement the singleton pattern. So we will create a public static UIManager. We will call this instance. And we're going to want a collection of target indicators. We'll import system collections generic. Okay, so in the awake method, if instance is not equal to null and instance is not equal to this, so somehow a duplicate instance of the UIManager is being created, we want to destroy that duplicate and just return. Okay, then if this is the first time we are instantiating a UIManager, we will save off the instance and we will initialize our target indicators list. Okay, we want a couple of public methods on this class. We want an add target method. And we will get the target indicator. We will instantiate a target indicator for this target. And we will parent it to the canvas. And then we will initialize that target indicator. We will pass in the transform for the target, and we will pass in a reference to the main canvas. And then we will add that target indicator to our collection. All right, very, very simple. Now we will add a method to remove targets from the collection. We will get the key from the specified target, which is going to be its instance ID. We will try to find an indicator for that key. We'll use link here. And I'm basically going to say if the indicator, if there's an indicator whose key equals the key for the target we're looking for, it will give us the first one that matches that condition. Otherwise, that will be null. And so all I have to do here is say if indicator. Basically, we found that indicator. Then we're going to remove it from the collection. Okay, now we need a method to enable and disable target indicators based on whether or not they're in that list of targets. So basically what's going to happen is the radar screen, which is where we already determine if there's anything within radar range, it's going to call this update target indicators method that I'm about to write, and it's going to pass in the list of targets that are within range. And we want to disable any target indicators for any enemy ships that are outside radar range. And so that's basically what this method here is going to do. So I'm going to call this public void update target indicators. Give it a list of transforms, which is going to be our targets in range. A Boolean, which is going to be the key for the target that we're locked onto, assuming we are locked onto one. And then, do I need a reference to our player? I'm not going to take that for now. I think that's all we need, actually. Okay, so we will loop through all of our target indicators. And then, for each target indicator, we will get their game object and set active on it. And then whether or not it's active is going to depend on whether our targets array that was passed in has a target whose instance ID matches the target indicator's key. So this is another link statement where basically we're taking this collection of targets, and any will return true if that collection contains any whose instance ID equals the target indicator's key. Right? So basically, we're going through all of our target indicators, which there's going to be an indicator for every enemy ship in the game. If they're in this list of targets that are in range, we're going to set it to be active. Otherwise, it'll be set to be false. And then we also want to set the locked on status, which is basically going to be true if the target indicator's key equals the key of the locked on target that was passed in. And I think that's it for the UI manager. So now we got to update our RadarScreen code. So let's see what we got here. Doesn't look like we need that using statement for anything. We need to add a couple of more fields to handle our targeting system. So let's add, we're going to add another float here, and I'll give it a range parameter. We'll go from 0 to 1,000. This is going to be our lock-on range. So we can only lock on to targets that are within this range. And we're also going to want to have a lock-on radius. And this will also, I'll give it a value from 0 to say 45 degrees. And I'm going to default this as something small, like 15 degrees. So basically, we're going to go through all of our enemy targets that are within range. If they're within this range and the angle from the ship to that target is within this, essentially the closest one, we're going to lock onto it. It's going to be a very simple algorithm for locking on. Looks like I have another variable I'm not using here. Okay, do I need to add anything to awake? I think I need to add a variable for whether or not we're locked on a target. In fact, I'm going to add a property for that. I'm going to add a transform locked on target. It will have a public getter and a private setter. Actually, I don't think it needs to be public. I think I'm only going to use it here. So in that case, it doesn't even need to be a property. Let's just do that. And I want to initialize that to null in the awake method. Probably not necessary, but okay. I think where we're going to want to make some changes is in late update. So in late update, we're drawing our target blips. I think in here we're going to want to tell it to update our target indicators. So we'll say UIManager.instance update target indicators. We'll give it our targets in range. We'll give it our locked on target. And if that's not null, we'll send in the instance ID for that, otherwise -1. We're going to give it our own transform, and we're going to give it our lock on range. I'm not sure I need that, but I think we don't need that either. All right, so where do we want to check to see if we're locked on to a target? I think we're going to want to do some stuff when we're refreshing our target list. So we'll go ahead and let Rider move that in there. I think right here we'll set locked on target to null. And just realized we don't want to include targets that are deactivated. If you remember, when an enemy ship is destroyed, we deactivate it. We set it's enabled to be false. So if this guy is not active, we're just going to continue and get the next target. Okay, we're going to want to have, we want to keep track of which target is the closest to us. So let's introduce a new variable up here. We'll call this closest, and we'll initialize it to our lock-on range. And we're going to add a new variable here. We're going to say closest equals, actually a new function. We're going to say try lock on target. We're going to pass in this target. I think I want to save off our position outside of this loop here. So I'm going to add a new variable called my position. It's going to be the transforms position. I'm going to pass that into this. And we're going to pass in the current value of closest. Let's create this function. All right, what do we want to do in here? First of all, we're going to save off the target's position because we're going to reference it more than once. We're going to calculate the distance from the target position to the ship. We're going to calculate the direction This is why I wanted to cache these values, because we're referencing them more than once. All right, and we're going to calculate an angle. That will be a vector3.angle. We're going to take that direction that we just calculated and use our transform forward. This will tell us the angle towards the target. And then we want to say if the distance is less than our closest, our current closest, and our angle is less than our lock-on radius, we'll set closest to be distance. We will set locked on target to be target. And we will return the closest value. So that becomes the new closest. Nice. I think that's all we need in here. So we're going to want to jump back out to the Unity editor. Let Unity rebuild these scripts. And here under UIManager, we need to add that script. We're going to assign our prefab for our target box. Did we not add a script to this? We did not. So let's go back into our UI here, drag in that target indicator script. We're going to want to drag in all the components for this. So let's go back to our prefab. And I'm just going to right click on this and say properties. All right. And let's see. So for target box, we'll drag in that. For lock-on image, we'll drag in that. And for off-screen image, we'll drag in that. All right, now we can go back to our UIManager, and we can drag in our target box prefab, and we can drag in our canvas. All right, now if there's only one thing missing, we need a way to tell the UIManager to add and remove targets. So let's go back into the Unity editor. And under UI and scripts, we're going to create a new script here, and we will call this Targetable. I'm not sure if that's a real word, but we're going to go with it. And this is going to be a much simpler script. We will, in onEnable, say UIManager.instance.addTarget, and we'll pass in our transform. And on disable, we will call a function called removeTarget. We need to create that function. And we will call UIManager.instance.removeTarget. We'll pass in our transform. And then in onDestroy, we will also call removeTarget. And we want to add that script to the enemy ship prefab. So I'm going to rename this prefab here enemy ship. And I'm going to rename this one player ship. Okay, and so enemy ship needs to have that script that we just created, targetable. And that should do it. Now there's one other thing I want to do before we test this. I want to go into project settings, and under script execution order, I want to add UIManager. And then I want to add targetable. And hit apply. And the reason I want to do that, this probably won't matter in the real game when we're done with it, because we'll be instantiating enemy ships after we start the game and after the UI manager has had a chance to initialize. But because we're using the singleton pattern, it's possible that this guy's awake will not be called before this guy tries to add himself as a target. So I just wanted to set that script execution order first. Let's come up here and look at that. There are target boxes, and you can see when I get close to one of them, he becomes the targeted or the locked on target. Now we still have an issue, or we're getting a null-reference exception for some reason, and we have an issue where we're displaying these guys even though they're off the screen, which we do not want to do. We'll handle that when we implement the off-screen indicator. We might have to check for null here. But let's implement this function and then see if we still get that error. So like I said, this is going to be the most complicated function for this feature. The first thing we want to do is we want to disable the target box, because that's an on-screen image and we are displaying the off-screen stuff. We also want to disable the lock-on image. And now we need to calculate where to render the off-screen image. So let's create a new vector 3 here. We'll call this indicator position. And we're going to do a little math here. We're going to take our main camera, convert that viewport that we've got to a screen point. So take the target viewport position. And we're going to subtract the screen center. And then we're going to multiply all of that times the signed value of the Z position. The reason we're doing this is because if the target is behind us, we need to flip these values to have it render correctly. And so this will basically, if this value is 0 or positive, it will return 1. If it's negative, it will return -1. So it basically is a shorthand way of saying if this is less than 0, multiply this by -1. All right. Let's see. We're also going to want to set our indicator position Z to be 0. And let's calculate our X and Y coordinates. So we're going to take our screen center dot X and we're going to subtract our margin. And we're going to divide all of that by the absolute value of our X position. And do the same thing for Y. Take our screen center dot Y, subtract our margin, divide that by the absolute value of our Y position. Okay, now we want to calculate this position based on whether X is less than or greater than Y. So if X is less than Y, then we're going to calculate an angle, which is going to use vector3.signed angle. We're going to calculate it from vector3.right using our indicator's position on the vector3.forward axis. All right. That gives us our angle. Now we're going to calculate our X and Y positions. So we're going to take X is going to be our assigned value times the width of the screen, or the center of the screen horizontally, minus our margin. We're going to multiply all of that times the canvas's scale. Now the Y position will be the tangent and we're going to convert this from radians to degrees, or I'm sorry, from degrees to radians. Multiply that times the angle that we calculated. And we're going to multiply that times our X position. So we're basically figuring out where we intersect the border. All right, otherwise, if X is not less than Y, we're going to calculate our angle, vector3.signed angle, vector3.up this time from our indicator's position, again using vector3.forward. The X position, I'm sorry, the Y position, we're going to take our assigned value, we're going to multiply it by the center of the screen on the Y-axis minus our margin, and we're going to multiply that by the canvas's local scale on the Y-axis. The X position will be the negative value of the tangent times the indicator's position on the Y-axis. All right. That position will be added to the screen center, which should, if we've done all the math correctly, position that arrow along the border at the appropriate position based on where the target is off the screen. And we're going to assign that to the rect transform's position. So now that's positioned correctly. Now we need to rotate the arrow correctly. So we will take its current rotation in Euler angles, We will set its Z rotation because we're just rotating on the Z axis. That will be the signed angle. From vector 3 dot up, indicator's position minus the screen center. Vector 3 dot forward. So that gives us our angle. Assign that back to the rect transform. And then we will enable that off-screen image. All right, all that just to display some arrows. Let's see if that works. Go back into the editor, clear this. Okay, let's let them go off the screen. Oh, there's some arrows. If I go up in those arrows, oh, it's beautiful. It is beautiful. And he's locked on. All right, we have targeting. Just got to fix these null-reference exceptions. So I'm not sure whether target is null or main camera is null. Probably main camera, because we might not have called a init before this late update starts happening. So I think what I'm going to do here is I'm just going to say if not target or not main camera, return. And I will clear those errors. Hit play. Ooh. I know. I need to disable those in the prefab. That's the problem. Those things are being spawned enabled. And I also don't want this here anymore. Let me override this. Let me come into here and say disable that image, disable that image, disable that image, apply all those changes to the prefab, and then delete that. And now nothing is being enabled. So it turns out that all I needed to do to fix that issue with the reticles not showing was to get rid of our little if statement that I had put in here, where I was checking to see if target or the main camera were null and just returning. I fixed the issue that I put that check in to fix initially by just making sure that the target indicator was disabled by default, that the images were all disabled in the prefab so that they weren't enabled when we first instantiated them. So that fixed that issue, and we can go back into the editor and we can see that we have all of our reticles showing up. I can lock on to targets. You can see the off-screen indicators being displayed. And we are not getting those errors in the console anymore. Well, that wraps it up for today's video. I think we made some good progress. We added some targeting ability, and now we can move on to implementing our seeking missiles. If you found that video useful, do me a favor and click the like and subscribe button. It really does help me to grow my channel. And be sure to be on the lookout for the next video where we will be implementing our seeking missiles. And if you want to be notified when I post that video, be sure to click that little notification bell. So thanks so much for watching, and good luck on your game development journey.